Some of the operations shown on the table and radial arm saws are for photographic clarity. We strongly recommend that you work with guards in place.
In the last video we built this nightstand as well as a hall chest. We left it where there's an opening for a door and a drawer. This video hopes to build you a drawer, give you all the ideas you need to build that drawer. This video will also help you build drawers for any other project. We're going to start with a little bit about nomenclature, parts of drawers. We're also going to tell you about drawer guides, drawer joinery, cutting and assembling of drawers, and general fitting of drawers. Let's first take a look at a drawer and its parts. Generally, the front of a drawer is the decorative part, and usually the only part we see, at least when the drawer is shut. This can be a number of styles. In this case, we've got a piece of plywood, in this case solid wood, and in this case solid wood. The drawer sides are the two sides, and they usually ride on some kind of guide or are attached to a metal roller device that controls the path of it. In this case, we have a place for a wooden guide, and that mounts to the sides. The back is usually trapped in a joint, a dado joint in this case, and we'll see how to make these later in the video, but they give you a snug fit between the parts. They also trap the bottom in a groove joint, and we'll see how this is cut later, but this gives us a captured bottom that holds the bottom in place and keeps the drawer snug and square. In some cases, the bottom simply slides in or out, and the reason for that is the type of joinery we have here does not allow it to be captured because we can't bend these sides back far enough to trap it. So the back on this drawer only comes down to the bottom of the dado, like so. This is a locking joint on the front, and this gives you more strength as you pull the drawer open. When you look at these two drawers, when you compare it to this one, there's a little clearance on the side, and this is called our rabbet. This is what we call an overlay, and we'll talk more about the types of overlays as we go through. And this has a locking type of corner, and you can see that the joinery here locks to the front in another fashion. These are the types of joints. There are a number of types of drawers that we can look at. From this point, we're going to go into the types of drawers and how they're classified. There are flush, lip, and overlay drawers. The first type is what we call a flush drawer. This drawer will be flush with the front when closed completely. And this is the type of flush drawer that you frequently see. The clearance around it allows it to be closed completely. The joinery here is similar to what you see here. We're going to go and take a look at a couple other types of drawers, and we're going to walk into the other room to take a look at those. This is a 3/8 lip drawer that has a lip or a part protruding that acts as a stop when you close the drawer. The lip on this particular one is formed by this molding, which has a rabbet or a recess cut. When we wrap it on or set it over this piece of plywood, it becomes the drawer front, and this becomes a 3/8 lip. There are other types of lip drawers that you'll see throughout the video. As you're watching, you get some other ideas of how these are made. This type of drawer is known as an overlay drawer. It has a decorative front that overlays the false front. We've used metal guides with this, and they act with the drawer front as a stop when the drawer closes. You might notice that we can have shorter drawer sides in this type of drawer, and this can be a desirable thing simply because now there's no chance of interference here. The other neat thing about having shorter drawer sides is, if you think about it, how full do you fill a drawer? Usually to the top of the sides. By having this clearance, there's much less chance that the drawer will ever stick or jam because of the contents. Now, we can change the look of an overlay drawer simply by changing the overlay or the decorative front. Right now we have a kind of a raised panel look. So the entire cabinet look can be changed by the type of overlay drawer we select. We're going to spend a little time talking about drawer parts, what their significance is and how they work. We're looking right now at the drawer fronts. In most cases the drawer front is a decorative part of the cabinet. Solid stock or solid hardwood is usually preferred. That is, if we have an oak cabinet, usually we have oak drawer fronts. This is solid wood here, and it will be, it's got a decorative cut on it. It can be a number of different types of cuts that we can use. You'll find that this is the preferred way. This might be an overlay or a flush drawer, but nevertheless hardwood solid stock is preferred. In some cases, to save money or for convenience, we use hardwood plywoods. We've got two different types of oak veneer plywood here. In this case we're looking at a piece of fiber core plywood, and in this case we're looking at a piece of veneer core plywood. Now when we look at the edges of these three pieces, the solid stock and the two pieces of plywood, I think you'll agree that this is a little nicer appearing. Yet if the drawer is flush, the only time that we see these edges is when it's open. In some cases we'll route a radius on the back and use that as a thumb pull. This is desirable because it hides that edge and also reduces the need of hardware. In less expensive drawers and in sometimes fancy cabinetry, we'll cut an arc out of the drawer, and this now can be used as the pull. It accommodates your hand. The drawer is no longer dust-proof, but I think you'll agree that this is a savings. Many times we can have as much money invested in the drawer just in the hardware we put on it as the drawer itself. So this is a savings. This is left over from a workbench drawer that I had made. I'd made several, and this is a leftover from that job. One other thing that I'd like to bring to your attention is the question of which way should the grain go on a drawer front. In most cases here you see the grain is going the long way, yet in this particular piece the grain is going vertically or the short way. Generally the preferred direction is to go the long way. This is more desirable. Yet in some kitchen cabinets where the drawer is immediately above a door, they extend the grain. That is, this would be cut off the same sheet of plywood, so the grain on the door will match the grain on this drawer. That is, it'll be an extension vertically on the cabinet. There is no right or wrong way. These are just some of the factors that one would consider when making a drawer up. Now let's take a look at some of the drawer bottom material that we might use. These are typical of the materials that you would use for a drawer bottom. In some cases we use a thin plywood. Other cases it's a little thicker plywood. This is roughly a 1/4 inch. This is roughly an 1/8 inch thick. This is a hardboard material. It's a 1/4 inch as well. Now in some cases we have a grain printed on it, and this can make a desirable drawer bottom. Other cases we leave it plain. How fancy the drawer is will determine this. In some cases even this thin material is nothing but paneling. Paneling can be used. You can save scraps from a job and use these as drawer bottoms in some cabinetry work. In other cases we use a coated type of hardboard. This was coated on one side, and this is for cleanliness. I think you'll agree that this would be nice in the kitchen, very easy to clean. There are other materials as well that are also hardboard. This particular one has a grain print on it, and it's been printed to look like red oak. This one has been printed with another type of clear material that's easy to clean. In most cases these materials have mating or counterparts that are compatible with them. For example, this is a manufactured drawer side, and it's designed to match the drawer bottom. These particular pieces were designed to match this drawer bottom. That is to say, we could make a drawer in this fashion. The beauty of this is all of the parts are the same. It's a compatible look and very desirable. These two drawer sides are only a couple of what we have available, and we'll move on to those in just a second. But I want to point out that these coated materials are available in a number of colors, and they can be used for drawer construction. In most cases these are much easier to clean and they require no finishing. This can be desirable in the long haul because you'll find that sometimes the greatest amount of labor is in the finishing of a cabinet. From a manufacturing standpoint, reducing that is desirable. Now let's take a look at some of our drawer bottom or drawer side stock. We saw some that was compatible and manufactured. Here are some other examples of what exists in the field. Now there are some duplicates here, and I just want to show you some of the similarities and differences. In some cases we will use a piece of plywood for a drawer side. Again, we see the veneers in the piece. This may not always be desirable. This can be used for inexpensive drawers, and we can minimize the look by radiusing that drawer. In other cases we'll use solid stock. Now, solid stock can be cut in a number of different ways. Here's a very short drawer side. Here's a little wider one. Both of these have some similarities in that they are solid wood that's been planed out of a little thicker piece. They are at a 1/2 inch, which is the typical drawer side thickness. This one's a little thicker than that. I think it's 5/8. We've radiused the top. These are solid stock. This is also solid stock, but I want to call your attention to this joint here, which we call a finger joint. And I think you can see it here or here. What we're looking at is two pieces of wood that have been glued end grain to end grain. This particular stock is purchased in 8-foot lengths or 16-foot lengths, and then it can be cut into sides. It already has this groove cut in it, and it's already been radiused on the top. These are nice in the sense that when we're manufacturing cabinets, or let's say you're doing an entire kitchen, you can buy this material ready-made and it'll save you a great deal of money. It can be a very good way of making the drawers quickly. These two pieces were planed out of solid stock, and the grain on these goes across. That is, if you look at the annular rings, they go this way. This is what we call flat sawn lumber. And in most cases, the expansion and contraction in this drawer side will be across. That is, this drawer will get wider and thinner depending on the moisture content or the humidity of the air. These, if you look at the ends, you can see the grain goes across them. This means that these will get thicker and thinner as moisture content changes. This is far more desirable because the dimensions of the drawer do not change as easily then. You won't have that binding problem that frequently is experienced with a very tight-fitting drawer. These particular pieces here have been glued up out of scraps. If you look at this, you can see it looks like 1, 2, 3, 4, 5, 6 pieces that are set side by side. These have been glued together, and we cut a groove in here. This particular one has been glued as well, and this is red oak, and these are strips of red oak. This is Banach, which is imported hardwood, and this is pine. When you look at the end grain, you can see that this, the grain goes across this, so this will get thicker and thinner as well. This piece of red oak is essentially the same. It's fewer pieces glued side by side, but again the grain goes across. This looks quarter sawn. We've radiused the top. And one other thing I want to point out to you is the medullary rays of the oak. This is a very pretty drawer side, and this is very desirable in high quality cabinetry. We can make these up, and we're going to spend a little time showing you how you can save some of your cutoffs to do that in just a minute. This one is the same in that we've glued several pieces side by side. The grain is not as visible because the color is so close in this part. Now, if we take a look at several what would be cutoffs or waste stock, you'll find that we could clamp these together with glue and make up a drawer side. Now, you say, well, that seems like a lot of work, but there are some techniques that we can employ. You've probably had a few pieces of stock like this left over after a job, and you say, well, it's firewood or we're going to throw it away. But yet, if you look very closely here, we've got 1, 2, 3, 4, 5, 6, 7, 8 pieces that could be used for stock in a drawer side. Now the interesting thing is this stock has been planed to a uniform thickness, And when we cut strips off this way and glue them here, we have planed edges that remain from the stock they were cut out of. So we have really no more work than ripping the strips and gluing them together. Once we build a cabinet, we'll find that the cabinet gets very little wear, but the drawer gets a lot of wear, in and out, all the time. It's important that these drawers be assembled correctly so that they can take that wear and stand the test of time. Joinery is very important. When you pull on the front of the drawer, the entire drawer should go along with you. We can do a number of things to make this an interlocking mechanism. Probably the simplest joint that we use is what we call the rabbet joint, and that's a rectangular L-shaped channel along the end of the board, and we fasten the side to that. Now there isn't a lot of strength there because we can pull apart. In this case, what we've done is we've added a couple nails there. Some people add staples or dowels. In any case, these will reinforce that joint and make it a lot stronger. Other joints that we use in the drawer is at the back. Frequently we use what we call a dado joint, and that's another U-shaped channel that allows us to slip the back in. Generally dados go across the grain and grooves go with the grain. The drawer bottom has been attached or slid into a groove. Now these terms are generally used interchangeably, but we'll be calling them dados and grooves as we go through the operations of making the parts. Now in some cases we combine the rabbet and the dado. For example, in this drawer you'll find that there's been a dado cut on the side and a rabbet cut on the front, and as we push those together we've made an interlocking joint. We've used the same dado, it's just a little bit larger at the back. This is what we call an overlay drawer, and we put another decorative front on this drawer to make it up. There are other joints that we can use in drawer construction. The dovetail is one of the most popular. And there are two types of dovetails that are frequently used in cabinet construction. This particular one is made with a router and a dovetailing device. This one here is made on the table saw or radial arm saw. This is a dovetail dado. And I think you'll agree that we can't pull these apart because the dovetail is trapped in there. The harder we pull, the tighter the joint gets. We've used the dado at the back again, and we've got a groove joint for the drawer bottom. In either case, this dovetail makes a very positive joint, and there's little chance this drawer will ever break down over time. Another popular joint is what we call the drawer corner. This is quite similar to the rabbet dado, but the fact is the front extends beyond it instead of just being a rabbet dado joint. This gives you a very decorative feature, and the front becomes an integral part of the drawer. We don't have to have a false front and a decorative front, we only have the original front. Also, we have that same kind of strength for pulling. We'll resist that pulling force and have strength and pass that test of time. One last joint that I want to talk about is what we call the locking corner joint. This one is similar to the drawer corner, except that it has a slight tenon that goes into the front. This eliminates any chance of it racking or going out of square. This type of joinery can be cut on the table or radial arm saw, and it takes a little extra time to make a joint like this. You'll want to practice on some scraps and develop some working drawings as you begin this little challenge. So as time goes on, you may find that this is what you'll want to build. Well, these are the types of joints we'll use. You'll find that careful marking, planning, working in scrap before you begin is very important to a quality joint. There are many other types of joints that you can use, and as time goes on you may even develop some of your own. It's just important to remember that there has to be strength between the front and the side so that this drawer can go in and out a number of times without failing. I'm bringing in an overlay drawer here, and by overlay I mean that there will be two fronts to it. This is a drawer that's nothing but a box, and we call this the false front. The overlay will be a decorative front that is attached to this, and of course the rest of the drawer will be in the opening. Now the nice thing about this is you can make this smaller than the opening and then just make the decorative drawer front the size to cover the opening. So it's a little easier to make, there's not as much challenge in this. There's all sorts, this is a full overlay drawer, this would be a 3/8 lip or 3/8 offset drawer. Either one of these types of fronts can be used, as well as others that you might design. Now, when we make this, we talked earlier at the bench about how we would set up a drawing, and here's the drawing. I'll turn it the same way that I would have the drawer. You can get an idea of what's going on here. The whole idea here is that a little planning at the bench goes a long ways. Many of the teachers that I've worked with in the past have a firm belief that if you can't draw it, you can't build it. And there's a lot of truth to that. A little planning on a sheet of paper can go a long ways. To make this up, I developed my bill of materials, and I have my parts already pre-cut. These will be the front and the back here, and these will be the sides. Oops, there we are. So, everything's cut and ready to go, at least to the desired lengths. These are relatively simple to make. First, I'm going to set the front and the back aside, that is way out of the way, so I can't work with those or make a mistake in cutting those. Now, the method I'm going to show you is the saw blade quick method, as I call it. It's something I developed, and I'm pretty proud of it because it works very well and it's very fast. A lot of times we can make 1 or 2 drawers faster than you can find the dado head with this setup. So we're going to go ahead and get ready to start. The first thing that we want to do is set our blade height to exactly 1/4 inch. Now, the grooves on this stock have been cut to a 1/4 inch depth, so everything will be the same here. What I have to do now is cut this, or set the blade height to 1/4 inch. And I can kind of eyeball that with the drawer side, and I can set it just a hair low if I want, and cut into it if I wish, or I can take a scrap and do that. Right now I feel pretty comfortable with where I'm at. The next setting is going to be to set the fence. Now I set this so that the outside edge of the blade, that is the side away from the fence, is even with the thickness of this saw, or with the stock that we're using for drawer sides. That's all it takes. Right there, it's even. Now, the first cut is simple. We do the same cut on all 4 edges of our drawer sides. Set this up like so, and we make this cut. And then this cut. Now if you look, you can see that that cut and this cut are equidistant from the ends of the piece, and they're the same depth as the drawer groove. This is very important. Now, I haven't cut this one yet, but let me just use this for an example. When I put this even like so, you can see that that saw kerf, I think you can better see it if I set this down like so. When this hits the table, the saw kerf is even with the thickness of the stock. Okay. Now, I'm going to cut the other side. Remember that I've cut on the drawer side of these. That faces down. That's another important thing to remember. I'm going to orient my pieces just as they would be mirror images. That is, I lift them up like this, and they become the right and left side. This is also important. Now, I'll set these over like so, and at the front of the drawer, I'm going to now move the fence closer by about 1/8 inch. That is, I'm just going to set my piece near the blade and move in like that. I've just moved the fence closer to the blade. Okay, now this cut will only be on the front of the 2 sides. Now the back has to be cut. What I'm going to do is I'm going to turn the pieces like so, and I'm going to set the drawer side over the saw kerf that we originally cut, and I'm going to mark the other saw kerf. Now I've got to reposition the fence for this cut. And I've got it positioned now. So what I have to do is I'll make that cut, move over, make another cut, move over, make another cut, and then I'll test my fit. So let's see what happens here. That's a nice fit. I'm real happy with the fit, so I'll cut the other side identically to it. I can check the fit again, but it should be the same. Very good. Slides in nicely. Could be a little tighter, but with the glue, there's just a few thousandths clearance, and that's all we really need for the glue. That'll tighten up nicely. Now, the drawer sides are done. The drawer back is done simply because it slips right into those two dados. We can set it aside as well. All we have to do is concern ourselves with the drawer front. Now, the drawer front gets cut on the front side. That is, the groove will be up when we make the cuts. And we can put this piece here like so to determine where the cuts will have to be made. Now, since this has gone in 1/4 inch, I can set the blade distance to the fence at exactly 1/4. And that setting should be right. Now we say, well, how high should the blade be? Well, I can position the pieces so that the front is flush with the side, and make another mark here like so. And that tells me how high the blade needs to be. Now I can set the blade a little too low and then raise it if I need to. Still looks like it may be a little big, but I'd sooner make a second cut, take a little bit more off. I'm afraid that I'm going to have to make a second cut on this. So I'm going to look at the side of the blade so I can see just how much it's coming up. I've got an idea. Still slightly tight. I can put my shoulder on here to check the depth. I may be a hair too deep. That's the fit I want. I think that the fence could be moved a little closer to the blade. That would move that over just a freckle, and I'll cut the other side and we'll see if that does any good. That looks to be a nice fit. And that would be the drawer excluding the bottom. Now, some other interesting things occur with this that I want to point out to you. Since when we look from this side, we can see that this tongue extends from the bottom of the drawer groove to the bottom of the drawer groove. So if I take this out and I measure this distance, this gives me the width of the drawer bottom. Takes the thinking out of the job. Now, so well, how about the length? Or we can call that the length and this the width, depending on how you're cutting it. We say, well, it's going to go from this point here to half of this. So if we look at this, we can do a little interpolating. In this case, it would be about 11 1/16. So we're able to do some measuring here. We can let our parts help us decide the size instead of making a lot of educated guesses. We can use our stock to control our dimensions and do an intelligent job of getting the piece cut the first time the correct way. So I'm going to set my parts aside and get some drawer stock out for the bottoms now.
After you assemble the drawer parts dry, measure the distance from side to side and back to back. This will give you the drawer bottom dimension. Use the table saw or radial arm saw to cut the bottoms to dimension. It's better to err to the larger side and cut again than to cut too small.
Now, I've got another drawer here that has the quick joinery that we showed you earlier demonstrating on the table saw. And I've got the sides, the front and the back, and the bottom's been cut. So what I'm going to do is I'm going to set the pieces in the order that I want them. And I'm going to glue them. I'm going to do it more in an industrial fashion. That is, I plan to use a nailer. And this will eliminate the need for clamps. First I'll put a light bead of glue in, just as I did before. And I've sanded these already, so there's going to be no problem there. You want to be prepared when you do this. Now the bottom in this drawer is captured, that is, it has to be slipped in now. I put it in like so. Now the drawer will pretty well stand alone like this, and this is nice. I'm not going to nail that side. I'm going to go backwards simply because it's a little faster and a little more convenient. Put my bead of glue on here. Then I'll take this part, line it up, tap it into position. Now when you nail them back here, you don't want to nail in the drawer groove, so you move up slightly. You push down like so. I'm going to turn it around so I can see the top and the alignment. You get a better idea of where the nailing ought to be. I could draw a line down there if I was a little unsure where my nailer needed to be. Now, I'll just check this again for squareness and give it a little push to bring it just about square. I'm happy with that, and I'll set it aside till the glue cures. Again, this drawer has a false front that's put on it, so I'm not so worried about any nail that might come through. Although I want a quality looking drawer, I can, after the glue cures, clean off that little bit of glue and readjust the fit if I need to. So that's what we do for assembly. Very simple. In some cases we're going to nail them together. We could use regular small-headed nails and use a hammer. We have the benefit of pneumatics here. Either way will allow us to do it. Even this drawer could have been clamped, so you don't want the nails in there. You want more of a drawer without any nails or fasteners, then you can glue and clamp. It takes a little longer. It depends on what you're trying to achieve with the cabinet you're building. So I'm going to clean up my gear here and get ready to fasten drawer sides. We've talked about selecting joinery for your drawers. Just as important as selecting the joinery is selecting the type of guide that controls the path of the drawer and the opening. Generally speaking, we have two types of guides. One is the monorail type, which is usually a guide that mounts under the drawer, and then we have what we call side guides, and these are guides that mount to the side of the drawer. Regardless of what type of guide you buy or make, you'll find that there are a few things you have to consider. For example, if you're going to buy them, with each type that you buy, you'll find that they provide you with a set of installation instructions, and this is a representative sample of those. Be sure that you read those carefully. They will give you allowances for clearances. These are very important because they determine how big the drawer ought to be. It can change the size of the drawer dramatically when you switch from one type of drawer guide to the other. Considerations might be the width of the drawer front, the width of the drawer sides. It might also affect where the drawer bottom is in relation to the bottom of the drawer. So all of these are considerations that you'll have to look at. And there's nothing wrong with trying to make a few scraps to see if it's going to work out before you make your actual drawer, especially if you've got something very nice that you're building. Let's take a look at a few of these guides, and we'll go from the simple to the complex, or from the very simple upward. Most of these that you see over here are made of wood, and these can be made from scraps in your shop. This type here would enlist a straight piece of stock, and this would attach to the faceplate and extend to the back of the cabinet. This piece with a dado cut in it would be attached to the bottom of the drawer, and this would slide back and forth. With time, you find that you may have some wear, so you're going to have to select your wood carefully. You'll also want to consider grain direction so your expansion and contraction is minimized, and that way variations in humidity do not affect the quality of the slide. Now another type of guide, I might add that this could be also used in another fashion on the sides. That is, these could be mounted on the sides of the cabinet and a dado could be cut in the drawer sides. Now this would slide back and forth, and the drawer front would cover this entire thing so that when the drawer front hit, it would stop. Another type of guide is made just by forming an L with two pieces of wood. This L then provides a shelf on which the drawer will slide. In this cabinet here we have these mounted inside. One is down below and the other is up on the top. So as the drawer opens up, the drawer doesn't drop down. Now these are very easily made, and there's prints for these in the Table Saw Techniques book. Now if you want to go on to some commercial hardware, or you're building larger projects, you'll find that there are some kinds of commercial hardware available, and some where you mix with homemade parts. This monorail type here is one that you mix with commercial parts. We've made a wooden monorail ourselves, and it's T-shaped. So now when the drawer opens, this plastic hooks on there so the drawer doesn't drop down. Now at the back of the cabinet you have a device like this. It's a wooden piece that has two dados cut in it. This sits in here like so, so it's free to move. So as you close the drawer, there is some tolerance or slop in here so that the drawer will close correctly. And you can make these very easily. On the faceplate we nail two of these devices here. And you can see they have a slight tack on them, and these are tacked to the faceplate. The drawer side will now slide on this very nicely, and this reduces the friction. There's no longer wood-to-wood contact. Larger cabinets require larger drawer slides. This particular one here is one of the newer ones on the market, and this plastic piece attaches to the drawer bottom. The back is set in here like so, and this slides forward. It has a stop so that the drawer can't be pulled all the way out. Notice here there's a little piece that stops it. These holes allow you to mount it to the faceplate. To release it, you simply push up from the bottom and push forward. At the back, this mounts to the back of the cabinet, and you'll find that when this is inserted, there's a little tolerance back and forth like this, so we can adjust that drawer before we screw it down securely so that we get a perfect fit. At the front we have these two little roller devices, and these mount to the faceplate. this wheel is mounted on an angle, so the drawer always rolls on that piece. This reduces the friction even more and makes the quality of the roll much nicer. Now, when we go on to this form of monorail here, we have a little different approach. This guide has a number of parts, and this is some consideration too. These two rollers mount on the faceplate, and they stick up above the faceplate. That is, if the faceplate is here, that wheel sticks up about 1/4 inch. So you're going to have to reduce the size of the drawer side 1/4 inch so this won't interfere with the top of the opening. A little consideration. This part up here attaches to the faceplate, and you can see there's an embossed center line on there, and you have to find the center of the opening. This is either screwed or stapled on. This then hooks over here and attaches to the faceplate. Now at the back we have this same plastic piece that screws to the back of the cabinet. This wheel attaches to the back of the drawer and controls the roll of the drawer. Now, there's a slight detent here, and this stops the drawer, and if you lift up on the drawer after that stop, you can remove it. You set the drawer in, it rolls back, and once it's past there, generally it stops there. There's no problem yet. It can be easily removed with a simple lifting action. Another nice monorail type is this one here. This has two parts. This part attaches to the bottom of the drawer. This attaches to the faceplate. This attaches to the back of the cabinet. It has a pair of rollers. Again, you have to subtract about 1/4 inch for the allowance of these. This attaches to the bottom of the drawer and then slides in. There's ball bearings throughout, so the fit is real nice. There's a snap action that lets you know the drawer is closed. Now, each of these are controlled by dimensions. For example, these are what we call 24-inch guides. That means that the depth of the opening is 24 inches. We could cut this off with a hacksaw and make it an 18 or something like this. But all of these things affect the size of the drawer. For example, this may be a 24-inch opening, but we can't have a 24-inch drawer simply because this wheel stops here, and this would have to be the back of the drawer. So we'd have to measure from here to determine the overall length of the drawer. All of these are important considerations when you start planning the drawer. Let's take a look at one other style here. This is what we call a side guide, and it has a ball bearing type of roller on it as well. It is stopped when you open the drawer, like so. This pin is pushed down here, and that allows you to release the drawer. Don't know if I can do it. Like so, and then the drawer comes out. So this is a nice stopping mechanism. Now, these drawer sides come in various lengths, and you can see that we have one attached here. If you look at these parts, you'll find that someplace on there will be two letters. Here it says DL. That means drawer left. This one here, not surprisingly, will say CL, cabinet left. Now, where these are positioned in regard to the front of the faceplate depends on how thick the drawer front is. So all of these things are considerations in the installation of the drawer guide. Again, there are some instructions to get you started, but there are certain things that change with the drawer style, and you'll have to consider these when you assemble them. One other thing that you might want to consider is that all of these drawer guides will be rated for weight. Now, this weight is very important. For example, a small drawer like this, certainly you wouldn't expect more than 40 pounds or so. So that would be fine. But in other cases where we put a light guide in and the drawer is overloaded, we're going to have problems. I've got an example of where I did this. I installed this in a doctor's office, and I thought this was going to be for office supplies. It turns out that they put in a bunch of files, and if you look at this ball bearing, you can see when you compare it to a new one. Let me get the other one. I cut this off to save just for this purpose. You can see the type of wear problems that one would experience. Now, this meant a call back to me, and that doesn't help on the profit end, but it also makes the job look bad. So always plan ahead. Make sure that you know what the drawer is going to be used for so you don't have those problems later on. One other type of side guide that's kind of unique is this one here. This has an L-shaped channel And this attaches to the bottom of the drawer. That is, the drawer side would rest here and you would screw into the drawer side instead of attaching to the side of the drawer. So this is another neat approach, a little newer approach to drawer construction, drawer guide systems. What I've showed you here does not exhaust drawer guides, but it gives you a general overview and a better understanding of how they work and how they interact with the joinery that you develop on your drawer. And we're going to spend some time installing a few of these later on, so you get a little bit of experience with that. One of the most important parts of the drawer's look or style is the drawer pull, or the hardware you use with it. We mentioned that for inexpensive drawers we could cut a handhole out like so, and this will keep the cost of the drawer down, and we simply use this as a pulling area. In some cases we route the bottom or the top so we can use that as a thumb grip as well. We can use some more expensive hardware, and we'll find that with smaller drawers, such as you might have on the nightstand, a single pull might be desirable. There's porcelain types, chrome, all sorts of antique brass that can be used, and a single on those tends to look nice because it's a smaller drawer. When we go to a larger drawer, we might find that a larger pull will look nice. We of course want to consider compatibility between the drawer and the door that will be beneath it. Sometimes we use actual wood, and we can stain the wood to be the same color or a slight contrast. Here you see a little bit of a contrast between the wood and the actual backing stain. So we can do this. This style here gives you more of a modern look. All of these things are determined by the hardware, or they tend to generate a feeling. Let's look at these for a minute. This top one and bottom one are essentially the same, except we have a piece of porcelain instead of a piece of brass in the center. Also, this has a back plate to it, and this back plate could fit under this one as well. The neat thing about a back plate is when you go to open that drawer, your fingernails aren't digging up the wood or the wood finish. So this is a real useful approach to what you're doing. If you want to protect the finish, you might want to use a back plate. Some of the more modern styles, again, are reflecting this brass, and the Euro style or European design uses wood again. Here we have a pull that looks like it's recessed, yet really it's a piece with two screws that attach it. There are other types that are the recessed type as well, and this is one here that is actually routed into the drawer. You can see that this is actually a piece of wood with a lot of machining, and this could be put on a plastic or a wood drawer front. On a plastic front, it would give the Formica or the plastic laminate the look of a wood, or the feel of wood when you opened it. So this is a desirable or a nice type of fit. This is also another type of recessed type that's made of plastic, and in some designs this is nice. These are also used on sliding doors as well. Now, these wooden pulls designed for being routed in or recessed into the drawer front always come in a plastic bag to keep the moisture content down, and this is an important thing as well. We don't want that to change because these would swell, and if we have a predetermined jig or fixture, they might not fit. A little later I'm going to show you how to route one of these in, but for now I want to move on and show you a few other things about setting hardware. One of the neat things about working with hardware, and one of the challenging things, is the actual installation of a pull on the front. Many of you have fought that battle of where do I find the center, how do I find the center, how do I divide that 32nd into portions. Let's take a look at a little device that I discovered, didn't discover myself, but I found and I've been using ever since. This is what we call a center finding ruler. I line one end up, and as I bring this other end over to the edge of the drawer, I've now found the center with this marker here, and I can lightly mark that. Now I can turn the drawer like so, find the center the other way, mark that, and then simply take my center punch and punch the center. Now, I'm sure that you say, oh, that looks easy, that's great, but what about a pull that has something like this where you have two holes? A little bit more of a challenge, huh? Well, there is a way of doing that. What we first do is line up the center line of the hole with the edge of the board, and here's the other hole. We line up, we line it up like so, and then we bring, let's do it this way. We bring this over to this point, and this determines the line on which this should be mounted. So now all I have to do is from this line measure over this distance, mark the other side, find the centers of those, and then I can attach this pull as well. So these are some things to make attaching the pulls a little easier. Now let's take a look at one other thing that's always a challenge with drawer construction and hardware installation, and that's the screws that come with these. In most cases, you're going to find that the screws are designed for 3/4 inch stock. Well, if your drawer front is 1/2 inch, then of course you've got to remove some, and that's a little bit of a challenge. We can use a hacksaw if we want, but one easier way is if you have access to a set of electrician's pliers, we can thread this into the pliers like so, and from the center line of the pliers to the underside of the screw head, that would determine just how long the screw needs to be. Then you can see the part that's going to be cut off extends through the back of the pliers. I simply now squeeze these like so and cut the bottom off. Now the beauty of this is I can remove that screw and the threads are undamaged at the bottom, so when I wish to drive those into the pull that I'm attaching to the drawer, I don't have a problem with it. So this makes it a very useful and very quick way. If you have 15 or 20 of these to do, you're going to find that access to this tool can be extremely useful. Well, I'm going to clear the bench now and set up to route that recessed pull, and we'll take a look at that operation. You'll get a better idea how that's done. So I'm going to pick up some of my materials, and I'll be back with a router and other devices I need. I've got my router set up for plunge routing, and this will allow me to go through my template here and route out the drawer front. I've got a drawer front like this clamped under here, and I'm going to cut the hole in which this pull will go. So I'll plug in my router and begin my cut. Well, let's see how the fit came out. A little snug. Don't think we'll need too much glue on this one.
Your finished drawer has now been assembled into the cabinet. With the drawer complete, we're now ready to begin construction of the cabinet door. Additional video modules are available regarding all aspects of cabinet making, from beginning to advanced construction.